What's going on, you guys? Mr. Allen here with, we got a lot of words on this one. Some linear regression. Gotta love it. All right. The linear regression model, y equals 170.3 x plus 205.6, is being used to estimate weekly mitten sales by Dr. Dre. He's getting a side business, you know what I'm saying? Right? The guy likes to diversify his portfolio. He's got the headphones, he's got the tunes, he's got the mittens. All right. Where am I? Where y is the total pairs sold and x is the number of weeks. All right. So we got a few questions here asking, what's the slope represent, y-intercept represent. We're going to estimate. And then also, is it a reliable estimate? Is it a good estimate based on our correlation coefficient? So let's get after it. First one, what does the slope represent in the context of this problem? Well, if y represents the total pairs sold and x is the number of weeks, then our slope, which is this 170.3, would be our number of pairs sold each week. All right, so let's write that down. Pairs of mittens sold each week. And it's good to be specific with those things, saying like number of pairs of mittens sold each week, and like putting in the each week, right? We can't just say number of mittens sold, because it's not. The total number is our y. It's the mittens sold each week. Okay. Next one. The y-intercept. What does that represent in this one? So since the y equals the total number of mittens sold, I would say that the 205, that would be at week 0, right? If I plugged in 0, that would give me my y-intercept in any situation, right? So when we're dealing with linear equations, really any equation actually that you encounter, if I put 0 in for x, I'm going to get a y-intercept if it has one, okay? So if I plug 0 in, I get 205.6. That would tell me that that's my total number of pairs sold at week 0, okay? So let's write that down and then see number of pairs sold at week 0. So does this really make sense? Let's think about it for a sec here. Maybe it's like their number of mittens sold before they started implementing this, regression model, right? Then that would make sense. But if they're just starting their business, they're not going to have 205.6 pairs, roughly, sold at week 0. So it depends on how we're going to interpret that one there. So depending on what they say, they might be like, does this make sense? Explain. You can explain that part. Like, yeah, until they didn't implement this model here, and when they did, they had 205 already sold at that point. Something like that. Or you could just say, no, man, it doesn't make sense to have 205 pairs sold when they just started their business. All right, we'll move on from that one. So a couple of little scenarios there for B. Part C here. How many pairs of mittens will be sold by week 12 according to this model? Now, we got to bust out our TI, all right? Normally I'd pop this thing up there, but this one's a pretty simple plug in, okay? So in this, all we're going to do here is in our calculator, it should look something like this. I'll jot it down right over here. We're going to have 170.3 parentheses. We're just going to put in 12, close them, plus 205.6. We're going to plug it in just like that into your calculator, whatever calculator you have. I obviously prefer the TI-84 Plus. Graphing calculator. All right, 170.3 parentheses 12 plus 205.6. Hit enter. We get, Dre's doing great, man. We got 2,249.2 pairs. So 2,249 pairs of mittens, right? Of what? Here we go. With these estimates, they might even say like to the nearest 100 pairs. So we say 2,200 pairs, roughly. Or they might say to the nearest 10 pairs. We'd say 2,250, right? There's, other than just saying like tenths and hundredths, the decimal places, you can also do it for the ones before the decimal and say to the nearest tens place or to the nearest pair. Right, 2,249 pairs then. Depends on what the question asks. This one didn't specify. I'm going to write it all down. Okay, last part here. If R equals 0.923, is this a reliable estimate or is this a decent estimate? Should we trust this estimate, right? And I always kind of hate these gray areas like, how do you feel about these numbers? Bro, this is math. I don't feel. I just do, right? So for this, though, for our correlation coefficient, when we're in that 0.9 and above, it's generally pretty safe to say that it's going to be a reliable estimate. I'm going to say yes. And you could cite that the correlation coefficient is above 0.9, so it usually means it's pretty decent, and things like that if they ask you to explain. I'm just going to do it in words rather than write it down. But that's it for this one, guys. That was fun. It's good stuff. It looks more intimidating than it actually is. So, Yay. See you later.